Hello there. So for today we will look into example where involve motion rounds a curve on a flat unbanked track. Okay, so example either we can have a car, motorcycle or bicycle. Okay, so on this example 4 we look at a car which has a mass 2000 kg, rounds a circular turn, radius given 20 meter. The road is flat and the coefficient of friction between tire and the road is given as 0.7. They want you to sketch a free body diagram of the car and then determine the maximum car speed without skidding. Okay, so for the free body diagram, okay, so the centripetal force or acceleration will act toward the center of the circle. Okay, so car will have mass, that means we will have weight acting, and then we will have a normal force. Okay, and then the force which will be holding the car without skidding will be the frictional force. Okay, so based on the diagram for y component, net y component will be equivalent to 0. Okay, therefore we can determine the amount of normal force which will be equivalent to n. Okay, whereas for the x component, net component or total x component will be equivalent to the centripetal force. Okay, so total Fx will be equivalent to Fc. If we expand the equation, we will get mv square over r. So since the only force that is acting in the x component is the frictional force, okay, what we can do is that we can replace in and then we can determine the velocity, okay, which will be 11.7. So if the car makes a turn with the velocity higher than this value, that means the car will skid off from the track. Okay, so for next example, we will look into a motion in a horizontal circle, which will be example 5. Okay, so in example 5, you have a ball of mass 150 gram attached to one end of a string given 1.1 meter long, and then the ball makes 2 revolutions per second in a horizontal circle. Okay, they want you to sketch a free body diagram and then determine the centripetal acceleration and the magnitude of the tension. Okay, based on the information given, mass converted into kg, okay, the length will be equivalent to the radius, okay, which will be 1.1 meter. 2 revolution per second will be the frequency. Okay, so this one, centripetal acceleration, will always act toward the center of the rotation. Okay, tension also will be in the same direction as the centripetal acceleration, and then the weight will be acting downward perpendicular with the tension. Okay, so the linear speed we can calculate by using the equation 2 pi r f. Okay, since we have the frequency, we can calculate the linear speed or velocity, so which will get with 13.8. And then for centripetal acceleration, since we have the speed, what we can do is that we can replace in and then determine the value of centripetal acceleration, which will get 173 meter per second square. Okay, which will be acting toward the center of the circle. And from the diagram, the centripetal force enables the ball to move in a circle, which also will be equivalent to the tension. Okay, so therefore the tension will be equivalent to the centripetal force. So from the calculation, m times with centripetal acceleration, which will end up with 26 Newton. Okay, for the last part, we will look into example 6 where we have a motion in a vertical circle. Okay, so this one you have a sphere, mass given 5 kg, tied to an inelastic string. It moves in a vertical circle, okay, radius given 55 cm at a constant speed of 3 meter per second as shown in figure. By the aid of the free body diagram, they wanted to determine tension at point A, D, and E. Okay, so for the solution, first thing we will draw the free body diagram. Okay, so for point A, tension will be acting downward. Okay, object will have mass, that means it will have weight, also acting in the downward direction. And for point D, the tension will be acting toward the center of the circle and weight will be acting downward. And for point E, tension toward the center upward and the weight will be acting downward. Okay, by referring to the free body diagram, we solve for point A first. Okay, since the object is placed upward, centripetal acceleration will act downward toward the center of the rotation. Okay, weight acting downward, tension also acting downward. Okay, so since the object is in a circular motion, net force will be equivalent to centripetal force. Okay, so therefore, since T weight in the same direction with acceleration, so T plus with weight will be equivalent to centripetal force mv square over r. So we solve it to determine the tension, which will be equivalent to 32.8. Okay, for point D, acceleration acting towards center. Okay, weight downward. Okay, tension also will be in the same direction as acceleration. Okay, since for point D, weight is acting perpendicular, so the weight will not produce or leave any effect with the tension. So therefore, the tension will be equivalent to the centripetal force. So just replace in the value where the tension will be equivalent to 81.8 Newton. Okay, and then for point E, okay, centripetal acceleration towards center upward, weight downward, tension also in the same direction with centripetal acceleration, which will be upward. So therefore, net force will be equivalent to centripetal force. So the E will be positive because the direction in the same direction as acceleration, minus with weight acting downward, which will be equivalent to the centripetal force. Okay, replace in the value and solve it, which will end up with 131 Newton. Okay, one conclusion that we can make over here for vertical uniform circular motion only, this one. Okay, the normal force or tension will be maximum at the bottom and it will be minimum at the top. Okay, that's all for today. Have a nice day.